Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and today we are going to do probability. In the previous session, we had done every chapter according to your syllabus. Right now, we are going to do probability. Questions on probability. So basically, we'll talk about exactly what is there in your syllabus. पहले वो उन चीज़ों को हम पहले देख लेते हैं, उसके बाद उनके ऊपर questions करेंगे. So are you guys ready? हेलो मोगिली, हेलो जीजे, वेलकम टू दिस सेशन. हाय यस, कैसे हो तुम लोग? आई होप यू गाइज आर डूइंग गुड. चलो फिर शुरू करते हैं विथ प्रोबेबिलिटी गाइज. सो देखो, शुरू करने से पहले प्रोबेबिलिटी का फॉर्मूला सबको पता है ना, कुछ भी नहीं है उसमें, तुम्हें भी पता है, बस उसमें सिचुएशंस डिफरेंट हो जाते हैं, तो सिचुएशन के हिसाब से यू हैव टू वर्क, राइट. सो पहले ये जान लो कि प्रोबेबिलिटी दो तरीके के होते हैं जो तुमने अब तक ग्रेड 10 में पढ़ा है, और इसमें से कौन सा वाला इन ग्रेड 10 आपके एग्जाम में आता है. ठीक है, तो सबसे पहली चीज ये है, देखो यहां बोर्ड पे तुम एक फॉर्मूला देख रहे हो कि प्रोबेबिलिटी ऑफ ई का मतलब क्या है, एक इवेंट. अभी मैं इसको एग्जांपल से तुम्हें बताऊंगा. इज इक्वल टू नंबर ऑफ ट्रायल्स इन विच द इवेंट अकर्ड, हैपेंड एंड टोटल नंबर ऑफ ट्रायल्स. सो ये बेसिकली तुम्हारे लिए क्या है, ये एक्सपेरिमेंटल प्रोबेबिलिटी है. दिस इज एक्सपेरिमेंटल प्रोबेबिलिटी. एक्सपेरिमेंटल या फिर इसको तुम बोलते हो इंपिरिकल प्रोबेबिलिटी. इंपिरिकल. अब ये चीज क्या है, दिस इज ऑन द बेसिस ऑफ योर प्रायर एक्सपीरियंस. मान लो कि तुमने एक कॉइन को टॉस किया 1000 टाइम्स. ठीक है, 1000 टाइम्स यू टॉस्ड अ कॉइन, और जिसमें से मान लो कि तुम्हें 650 टाइम्स हेड्स मिले. 650 टाइम्स हेड्स मिल गए, तो टेल्स कितने मिलेंगे बताओ यहां से. तो टेल्स तुम्हारे को मिल जाएंगे 350 टाइम्स. ठीक है, तो अब देखो ये तुमने एक एक्सपेरिमेंट कर लिया. यू ऑलरेडी हैव गॉट अ सेट ऑफ डेटा विथ यू. सो ऑन द बेसिस ऑफ दिस डेटा, ऑन द बेसिस ऑफ दिस प्रायर एक्सपीरियंस, इंपिरिकल का मतलब होता है ऑन द बेसिस ऑफ योर एक्सपीरियंस. यहां पे अगर मैं तुमसे बोलूं कि अगर दोबारा हम कॉइन टॉस करते हैं, सो व्हाट इज द प्रोबेबिलिटी ऑफ गेटिंग अ हेड, तो तुम बोल सकते हो कि इट विल बी 650 अपॉन 1000. क्लियर है, यानी 0.65. तो ये क्या है, एक्सपेरिमेंटल प्रोबेबिलिटी या इंपिरिकल प्रोबेबिलिटी है. हाय शकील, हेलो मानुआरा. एग्जैक्टली. नहीं रुक जाओ शकील, यही मैं तुम्हें समझा रहा हूं, सही से सुनो. ये बहुत इंपॉर्टेंट बात है, इसको सुन लो. 2 मिनट का टाइम लगेगा, ये चीज सुन लोगे, बाकी क्वेश्चंस तो तुम्हें पता है, वो हम करने ही वाले हैं, है ना. तो दो तरीके की प्रोबेबिलिटी फिर से मैं जल्दी से रिपीट कर रहा हूं, ये है इंपिरिकल या एक्सपेरिमेंटल प्रोबेबिलिटी. तो यहां पे क्या, नंबर ऑफ ट्रायल्स इन विच द इवेंट अकर्ड अपॉन टोटल नंबर ऑफ ट्रायल्स. इसका मतलब क्या कि तुमने एक्सपेरिमेंट पहले किए हुए हैं, ऑन द बेसिस ऑफ दैट एक्सपीरियंस तुम प्रोबेबिलिटी निकाल रहे हो. सपोज करो तुमने 1000 टाइम कॉइन को टॉस किया था, जिसमें से 650 टाइम्स तुम्हें हेड मिले और 350 टाइम्स तुम्हें टेल मिले. तो अगर अब तुमसे पूछा जाएगा कि अब तुम अगर कॉइन टॉस करोगे तो प्रोबेबिलिटी ऑफ हेड क्या है, तो तुम ऐसे बता दोगे. ठीक है ना. तो ये क्या है, ऑन द बेसिस ऑफ प्रायर एक्सपीरियंस, तुमने पहले से एक्सपेरिमेंट किए हैं, तो ये एक्सपेरिमेंटल प्रोबेबिलिटी इसको बोलते हैं, या इंपिरिकल प्रोबेबिलिटी. ठीक है, ये बात समझ में आ गई. तो ये जो चीज है, ये तुमने ग्रेड 9 तक किया हुआ है. इसमें आसान क्या है कि तुम्हारे को पहले से आउटकम्स गिवन होते हैं, क्योंकि तुमने पहले से एक्सपेरिमेंट कर लिए ना. तुम बात समझ रहे हो, तुमने पहले से ही वो एक्सपेरिमेंट कर लिए हैं, उसके बेसिस पर तुम फ्यूचर के लिए प्रिडिक्शन कर रहे हो. आई होप यू अंडरस्टैंड दैट. लेकिन अब जो ग्रेड 10 में तुम पढ़ते हो उसको बोलते हैं थ्योरेटिकल प्रोबेबिलिटी. इसको यहां पे क्लासिकल प्रोबेबिलिटी भी बोलते हैं. सुनो, इसको बोलते हैं क्लासिकल प्रोबेबिलिटी या थ्योरेटिकल प्रोबेबिलिटी. अब यहां पे क्या है, तुमने एक्सपेरिमेंट किया नहीं है, तुम पॉसिबल आउटकम्स के बारे में बात कर रहे हो. यहां पे देखो फॉर्मूला क्या है, नंबर ऑफ आउटकम्स फेवरेबल टू ई अपॉन नंबर ऑफ पॉसिबल आउटकम्स ऑफ द एक्सपेरिमेंट. तुम समझ रहे हो, पॉसिबल आउटकम्स की बात हो रही है यहां पर. एग्जैक्टली तुम्हें पता नहीं है कि आउटकम्स क्या आएंगे. फर्क समझ में आया शकील? आई होप समझ गए होगे. देखो तुम्हें ये फर्क दिख रहा है, ये क्या है, नंबर ऑफ आउटकम्स फेवरेबल टू ई अपॉन टोटल नंबर ऑफ पॉसिबल आउटकम्स. और एक्सपेरिमेंटल में थे क्या था, नंबर ऑफ ट्रायल्स इन विच इवेंट अकर्ड अपॉन टोटल नंबर ऑफ ट्रायल्स। ट्रायल्स का मतलब क्या हुआ, जैसे एक बार टॉस किया तो एक ट्रायल, दो बार टॉस किया तो दो ट्रायल, इस तरह से। तो यहां पे तुमने पहले से किया हुआ, यहां पे तुमने एक्सपेरिमेंट किया नहीं है, तुम बस पॉसिबल आउटकम्स के ऊपर बात कर रहे हो। क्लियर है? हेलो शिवानी, हाय बाबूआन, हेलो विघ्नेश। ओके, नो प्रॉब्लम। So is it clear? Over here you're talking about theoretical probability or classical probability. Over here you haven't done the experiment priorly, right? But if you talk about experimental or empirical probability, over here you already have done experiments in the past. On the basis of that experience you're deciding probability of some event. You got it or not? So there is a difference between these two. Now you will ask why we are doing these two types of probabilities. That question you may ask, right? Suppose we are talking about tossing a coin. So tossing a coin is very easy. You can do it at your home. You can toss it 5,000 times. It's all up to you. But suppose if we are talking about launching a rocket, launching a satellite basically. So can you do trials in that? Can you launch a rocket 15 times? Can you do that? Thanks, Rifka. Yes or no? You cannot launch a rocket 5 times and then 15 times and then you will talk about the probability in that case. That is not possible because that's a very costly affair. You cannot launch satellites just by doing experiment, right? So in those cases, you talk about theoretical probability or we call it classical probability. So there is a difference. Over here, the formula is number of outcomes favorable to E. E is an event over here upon number of possible outcomes of the experiment. Clear? So suppose, see, if you toss a coin, what are the possible outcomes? If you toss a coin, the possible outcomes are head or tail. So probability of head, you call it, you will say 1 by 2. Yes or no? Or probability of tail is 1 by 2. So you see, in theoretical probability or classical probability, probability of head will every time be 1 by 2 or not. When you toss one coin, probability of head will every time be 1 by 2. It will never change. But in case of experimental probability, probability of head can be anything. It depends on your previous experience. For example, this was for one person, but suppose some other person had some another experience. He tossed the coin 100 times, but he got 30 heads in that case. So probability of head in this case will be what? 30 upon 100, yes or no? So this will give you 0.3. So basically experimental probability or empirical probability depends, it varies from person to person, but theoretical probability can never change because it is theoretical. You got it or not? Tell me, Babuan, is it clear? Very important concept this is. But it has been seen that as you increase the number of trials, probability of an event it goes closer to its theoretical probability only. Suppose in case of tossing a coin, if you keep on increasing the number of trials, automatically it has been observed that probability of getting a head will come closer to 1 by 2. Is it clear? This is a very important concept. I hope it is clear. So that's all about formula. I'll repeat one more important point which is very important. If it comes in the examination, a question on probability, you have to compulsorily write formula. I have seen many students, they don't write the formula. I mean, they just write the answer. No. If it's a probability question, you have to compulsorily write the formula. And 99.99% chance is there that in grade 10, you will get theoretical probability questions only. Because empirical probability or experimental probability was there in grade 9. I hope it is clear, Vignesh. I am speaking in English only. Is it clear? Rudra, Babuan, Rifka, Shakil, Vignesh. So don't forget to write this formula whenever you get a question on probability. Okay? Now let's see some other things related to probability. Some 3-4 points are there and then we'll be doing questions only. Nothing more will be left. The sum of all the probabilities of the elementary events of an experiment is 1. For example, you roll a die. What are the possible outcomes when you roll a die? The possible outcomes when you roll a die are 1, 2, 3, 4, 5, 6, right? Now what is the probability of getting 1, guys? Probability of getting 1, probability of getting 2 is equal to probability of getting 3 is equal to probability of getting 4 is equal to probability of getting 5 is equal to probability of getting 6, and isn't it equal to 1 by 6, guys? Tell me. So getting 1 is an elementary event. Elementary event means an event in which only one outcome is there. You got it? So probability of all of these events is equal to 1 by 6. Now if you sum these these probabilities, what will you get? Suppose you do probability of 1, probability of 2, and up till probability of 6 if I do, what will I get? Will I get 1 by 6 times, guys? Tell me. So will I get 1 over here? So therefore it is written that the sum of the probabilities of all elementary events of an experiment is 1. Is it clear? Sample space means the set of all possible outcomes of an experiment is called its sample space, Babuan. For example, if you roll a die, its sample space is 1, 2, 3, 4, 5, 6. This collection of all possible outcomes, the collection of all possible outcomes of an experiment is its sample space. So I am not using that term because it is not mentioned in the CBSE syllabus, otherwise other students will get confused. So is it clear? These sum of probabilities of all the elementary events of an experiment is 1. I hope it is clear. Chalo. Now one more thing is there. For an event E, P of E dash is equal to 1 minus E dash. Basically, what happens is, suppose an event is E, right? So there is another event not E. So not E is represented by E dash, or you write it like this, E bar as well. Okay? For example, I'll explain with examples, you'll get it immediately. For example, in this case itself, if I find the probability of getting 1, so probability of getting 1 is 1 by 6, guys. Now what is the probability of getting not 1? Can you tell me? Probability of getting not 1? So apart from 1, 5 other possible outcomes are there. So probability of not 1 is 5 by 6 or not? Tell me. So if you add these probabilities, probability of 1 plus probability of not 1, what is this equal to? Isn't it 1 by 6 plus 5 by 6? And if you add, you'll get 1. Therefore, for any experiment, probability of an event, therefore it is written over here, probability of an event E and the probability of an event E dash, their sum is 1. Is it clear? Basic concept. See, these things were there in grade, okay, this was not there in grade 9, I'm sorry for that. So you write it like this, probability of an event E plus probability of an event, you write it E dash as well, it's up to you. You can call it E dash or you can call it like this, E bar. Both of these will do. You got it, guys? Wait, there is some issue. Probability of an event E plus probability of an event not E is equal to 1 every time, and this will be used to do questions. Any doubt in these concepts, tell me. Very basic logic these are. You can get some objective questions as well on the basis of these concepts, right? Okay, one more thing over here. I'll again explain it using example. Suppose that example only of rolling a die. So the set of all possible outcomes, or you can say sample space, 1, 2, 3, 4, 5, 6, when you roll a die. These are the set of all possible outcomes when you roll a die. Clear? Now suppose, just hear to it very patiently, very important, very interesting thing it is. Suppose if you roll a die and I ask, what is the probability of getting 7? Can you tell me? What is the probability of getting 7 when you roll a die? Tell me quickly. Deshika, Shakil, Manuara, Babuan, Vignesh, Rifka. Can you tell me what is the probability of getting 7 when you roll a die? Obviously a normal die. You are not talking about any different thing. So probability of getting 7 when you roll a die will be 0. Very good, because you don't have 0 over here. So probability of getting 7 when you roll a die will be 0 over here or not. So this event, getting 7 when you roll a die, getting 7 when you roll a die is an impossible event in case of this. Okay? Getting 7 when you roll a die is an impossible event. So probability of an impossible event is every time 0. Is it clear? Yeah, Shakil, you can understand like that because all possible outcomes are 6 only. But out of those possible outcomes, none of the options, none of the outcome is a favorable outcome. So you can say 0 by 6 or not, Shakil. Tell me. So this is an impossible event. Suppose I ask one more example, probability of getting a negative number when you roll a die. What is the answer to this? Probability of getting a negative number when you roll a die? Tell me, guys. Probability of getting a negative number when you roll a die. Tell it quickly, guys. See, concepts are very simple in probability, but you know it depends on situations. Questions can be different, right? Okay, so Manuara is telling 0. What about other students? So when you roll a die, you cannot get the negative number, obviously. So its probability will again be 0 by 6. You can understand like this. So getting negative number is also an impossible event in case of rolling a die. Getting a negative number is an impossible event. So therefore, probability of an impossible event is 0. Now suppose if I ask a question, probability of a number. If I write probability of a number when you roll a die, what will you get? Tell me. Probability of a number, of getting a number when you roll a die. Exactly. Yeah, you people are correct. What about this thing? So probability of getting a number over here, just tell it quickly, guys. I'll explain that, Babuan. Wait for it. First see this. Tell me, what is the probability of getting a number when you roll a die? Exactly, it will be 6 by 6. Very good. Because you see, all the possible outcomes are numbers only, na? Are they any other things? Are they letters? They are numbers. So probability of getting a number when you roll a die is 1. So therefore, this event is called a sure event. This will happen for sure when you roll a die. So this is a sure event. Clear? So therefore, probability of a sure event is 1 and probability of an impossible event is 0. That is very simple, right? Very simple logic you must have already seen. Mehboob and Amazing, it is 1 over here, Mehboob. A number means any number you can get over here, right? So it will be 1 only. You got it, Mehboob and Amazing? Exactly. Now suppose I ask probability of sun rising in the east. What is the probability of the sun rising in the east? Tell me. Very simple question. You must have seen this in books. Probability of the sun rising in the east. Tell me. What happened, Amazing? Are you not able to understand that? So what is the probability of the sun rising in the east? Tell me. Exactly, the sun will for sure lie in the east. So its probability is 1. Yes or no? So this is a sure event. So the sun rising in the east is a sure event. Therefore, its probability is 1. You got it? Now let's see one thing which is very important, for which that is written over there. See, if you talk about probability of any event, if I show like this, in this case, in case of rolling a die, if I explain, see, the maximum value which can come in the denominator is 6. You got it? The maximum value which can come in the denominator is 6 only, na? And the minimum value which can come in the numerator is 0. Because you cannot get less than 0. Because you're counting things. It can never be negative. It can never be fractional. So it can be 0 and maximum it can be 6 or not. Tell me. So therefore, can you not say that the minimum value of probability is 0? And you can say that maximum value of probability is 1 or not. You got it? So that is the proof of it. Because the numerator in any case can never be greater than the denominator, na? Because the denominator is the set of all possible outcomes. So when you do an experiment, how can the outcomes which you are getting be more than the all possible outcomes? It can never happen. So therefore the probability of an event every time lies between 0 and 1. It can never be negative and it can never be greater than 1. Is it clear to every student over here? Hello Pikachu, yes, I'm doing good. I hope you're doing good as well. Hello KK Queen. Is it clear to everybody in this session? Bilkul, we'll be doing questions, don't bother Shakil. 2-3 minutes more and then we'll be doing only questions. Don't bother, and I will cover every type of question which is there in your syllabus, don't bother. I hope it is clear. बिल्कुल करेंगे शकील, रुक जाओ थोड़ा सा, एक दो चीजें बातें पहले सुन लो. अभी जैसे यहां पे एक चीज और थी, wait, give me some seconds. Yes, equally likely events. Equally likely events क्या है? बाबुआन ने भी पूछा, what are equally likely events? So equally likely events means events having equal probabilities. You understand from its English itself, equally likely. It means their likelihood is equal. For example, if you roll a die, the set of all possible outcomes are 1, 2, 3, 4, 5, 6. So can you not say that probability of getting 1, 2, 3 and all that up till 6, they will be equal or not? Up till 6, it is 1 by 6 only. So you will say that getting 1, 2, 3, 4, 5 and 6, in case of rolling a die, they are all equally likely outcomes. Their probabilities of happening, they are equal. Is it clear? Thank you, SSS33YT. Is this clear? What is the meaning of equally likely outcomes? Babuan, any doubt in that? Tell me. So that's all about concept, guys. We are going to do questions now. So what you know about questions in this chapter is you have to understand many situations properly. For example, the situation of cards, the situation of coins, the situation of dice. These three are the most important situations on which you can get a question. Okay? So let us do questions, guys. So first we'll see the situation of cards. Although it is very simple, still I had taken this for you, right? So in total you have got 52 cards, right? In a pack of cards, in a well shuffled pack of cards, you have got 52 cards in which 4 groups are there, yes or no? 4 groups are there of 13 cards each. 4 groups are there of 13 cards each. So 13 cards are spades, 13 are clubs, 13 are diamonds and 13 are hearts. Yes or no? Out of which diamonds and hearts, they are red colored cards. Diamond and hearts are red colored cards. And spades and clubs are black colored cards. You know this already. Spades and clubs are black colored cards. Is it okay to every student over here? Now in every group of 13 cards, a king is there, a queen is there, a jack is there, an ace is there, and cards numbered from 2 to 10 is there. You got it? So therefore 1, 2, 3, 4 and 2 to 10 over here, 9. So total 13 cards in each group. Any doubt in this? Okay, fine. कोई बात नहीं शकील. Clear है सबको? Jokers की बात we are not doing over here spot on level. I hope you understand that. That is a different type of set, so we are not talking about jokers. We are just talking about jacks over here. I hope it is okay. नहीं, जोकर को जैक नहीं बोलते शकील. ये कंफ्यूजन मत पालना, ठीक है? जैक ही आएगा, बस ये समझ लो. देखो, we are working according to board exams or not? Are we going to play cards? Just tell me that. हमें cards खेलने हैं क्या? ये बता दो बस. We don't have to go into that now. We don't know. We don't want to be some bluff master or something like that. We are not going to play cards. हमें बस इतना पता होना चाहिए which will come in the examination. That's it. So ये चीजें होती हैं. Apart from that, don't bother about any other thing. Now one more thing is there. A king, a queen and a jack, they are known as face cards. The simple logic is because they have got faces made on them. A king, a queen and a jack, they are known as face cards. So how many face cards are there in total? 3 cards in each group of 13. So total 3 into 4, 12 face cards are there. That's it. Done it is. Any doubt in that? Tell me. Oh, I don't know that spot on. I never have played cards, right? And I don't need to know that. I hope you understand that. We don't have to play cards, guys. Oh my God, come on. We just have to do questions on cards. Yes, I'm speaking in English, Deshika, don't bother. I hope it is clear. So total, no, that is not 13 into 4. 3 into 4 face cards are there. I hope that is okay. I hope you understand. See, if you don't understand Hindi, but sometimes I will speak Hindi, you don't have to bother. Your concepts will not get hampered due to it. Please manage, right? Because some students, they don't understand complete English. Some students are there, they don't understand complete Hindi. So please understand my situation as well. You understand that? Oh, I don't know that, Shakil. I don't need to know that, because it will not come in my examination, in your examination, right? Face cards, total face cards are 12. The reason being, you see a king, a queen and a jack, they are face cards. The simple reason is they have got faces made on them. So in a group of 13 cards, 3 face cards are there. So 3s are 9, 3, 6, 9, 12. Total 12 face cards are there. Is it clear? Yes, spot on level. Oh yeah, that is correct. Total number of cards is 52. That is correct. I had already said that. Total number of cards is 52 over here. Okay, fine. I hope it is clear to everybody. Any problem in this? See, questions will come. My goodness, please understand that. Nobody is going to ask in the examination, please explain a pack of cards. No, a question will come on the basis of that. But Shakil, it is not there in CBSE. So let us start with questions, right? Okay, so what about this? What is the answer to the first part over here? Tell me. One card is drawn from a well shuffled. You understand well shuffled? You do like this? Well shuffled deck of 52 cards. Calculate the probability that the card will be an ace. I have never done that. I've just seen. Don't think that I do that regularly. It's okay. Try to be on time. What is the answer to the first part over here? What is the probability of getting an ace when you draw a card from a well shuffled deck of 52 cards? Tell me quickly. Oh my God, you must have answered it within 5-10 seconds, guys. Face cards. You don't have a number on face cards, Vinay Kumar. You don't have numbers on face cards. King, queen and jack, they don't have numbers written on them. Numbers are 2 to 10 only, right? Exactly. Face cards. So total, how many aces are there in a pack of cards? 4 aces will be there. See, 1 ace in each of these groups, right? So 4 aces will be there. So probability of getting an ace will be 4 by 52. So the answer is 1 by 13. Clear? Probability of getting an ace is 1 by 13. Is it clear? We don't have to bother about sequence numbers, Vinay Yadav. That's what I'm saying. 1 by 13 is the probability of getting an ace. Is it clear? Oh, no problem, Vinay Yadav. We don't need to know that. You understand that or not, Vinay Yadav? Nobody is going to ask what is the sequence number of face cards. I didn't know that in my whole life, but I have done every question on the basis of cards. You understand that or not? I hope you understand that. Now, what is the probability of not an ace? Probability of an ace we have got. Probability of not an ace will be what? You can tell it quickly. Exactly, that is correct. Spot on, Babuan. Very good. Exactly, Shakil, that is correct. Very basic question it is. So probability of not an ace, see, getting an ace and getting not an ace, they are complementary events or not? Tell me. Getting an ace and getting not an ace, they are complementary events. So directly, probability of not an ace will be 1 minus probability of getting an ace. Is it okay? So 1 minus 1 by 13. So if you simplify, you'll get 12 upon 13. Is it clear? So probability of not getting an ace will be 12 upon 13. That's it. Very simple. Let us do as many questions as possible. Yeah, you can do like that as well. For example, Bhagwan Das told like that. Bhagwant Das, if I'm pronouncing it correctly. Bhagwant Dara. I'm sorry, my vision is a bit weak. So I'm not able to see it properly. Okay, fine. No problem, Vinay. Okay. I hope it is clear. Now what about this? A card is selected at random from well shuffled deck of 52 cards. The probability of it being a red face card. Probability of getting a red face card when you draw a card from a well shuffled deck of 52 cards. Tell it quickly. Do it quickly, guys. Let me know the answer. So red face cards, how many face cards are there? See, red cards are what? Hearts and diamonds. Yes or no? Hearts and diamonds, they are red cards. So you know that 13 hearts will be there and 13 diamonds will be there. Yes or no? So 3 face cards of hearts will be there, 3 face cards of diamonds will be there. So total 6 face cards will be there, which will be red in color. Yes or no? So the probability will be 6 upon 52. That's it. This is the answer. So what is the answer over here? 3 upon 26. Probability of getting a red face card when you draw a card from a deck of cards. Option 1 is correct over here. Why are you getting 1 by 2? Red face card we want, not red card. Red face cards. You got it or not? Not only red card. Oh my God. We want red face cards only, not only red cards. We are talking about red face cards. It means king, queen and jack of hearts and king, queen and jack of diamonds. So 6 red face cards are there. So 6 upon 52 is the probability. Yeah, red face cards, not only red card. Hi Milan, welcome to this session. Hello Tanishka. Is it clear to everybody over here? Just tell me quickly. Try to do as many questions as possible, guys. Questions will come in the examination. And one more thing I would like to say over here. Don't do like this in the examination, right? I'm explaining it, therefore I'm not writing every formulae. If it comes in the examination, you have to compulsorily write the formula over there. Is it okay with you guys? You have to compulsorily write that probability of an event E is number of favorable outcomes upon total number of outcomes. You have to do that in every question. Please ask your doubt, just write your doubt, Milan, I'll see that. Okay, fine. Let us take the next question. What about this? See, 5 questions are there. What is the answer to the first part? A king of red color. Tell me. Let us do it quickly. So first we'll do cards and then we'll talk about coins and then we'll talk about dices. So that is the thing which will be there in the question. Okay, Vinay Kumar, don't spam. Please understand that. Please don't spam. I got your point. It is not going to be asked. Please understand that it's not going to be asked that what is 11, 12 and 13 number cards. Please understand we are doing according to CBSE grade 10 boards. Yes or no? Please don't spam if you understand it, because it's going to disturb other students. So understand that. So probability of a king of red color. So again, what are red cards, guys? Hearts and diamonds are red cards. Hearts and diamonds are red cards. So 1 king in hearts and 1 king in diamonds. So the probability will be 2 by 52. That's it. So it is 1 upon 26. Don't leave it, guys. Just simplify it up till the maximum extent. So probability of getting a king of red color will be 1 by 26. That's it. That's it. Done within seconds. No, 2 upon 52, Deshika. I hope you understand that. Exactly, Jayashri. Very good. Very good. It's a direct question. Very good. What about the second part? Probability of a face card. These things must be on your tips like this. You cannot say that I have forgot these things, guys. Understand that. Oh, it is not a logic spot on level. It's just, you can say, pure memory based thing it is, actually. It is a memory based thing, right? Face cards means, see, king, queen and jack are called face cards because they have got faces made on them. That's it. So 3 face cards will be there in spades, 3 in clubs, 3 in hearts, 3 in diamonds. So in total 12 face cards are there in a pack of 52 cards. Okay. So 12 face cards will be there. So the probability will be 12 upon 52. So 4 3s are 12, 4 1s are 4, 4 3s are 12. So 3 upon 13 is the answer. Probability of getting a face card is 3 upon 32. Is it 3 upon 13? Sorry. Is it clear? Exactly. Very easy. What about the next part? Let us do it many questions. We have got to do many more questions. Don't bother. This is just cards, guys. What is the probability of getting jack of hearts? Tell it quickly. Tell it quickly. Jack of hearts. Okay, 3 upon 13 was of face cards, right? Yeah, that was of face cards. Correct. Very good. Now, what is the probability of getting jack of hearts? Tell it quickly, guys. Tell it quickly. Okay, no problem, spot on, I got you. मैं मान गया आपकी बात. Questions करो अब यहाँ पर. Jack of hearts. Exactly, in hearts you have got only 1 jack. So its probability will be 1 by 52. That's it. Jack of hearts, its probability is going to be 1 by 52. That's it. Very good, very good. Jayashree, Babuan, Vinay Kumar, Shakil, Babuan, Christopher, Bhaskar, Tanishka. Very good. Very good, Akshita. Very good. What is mutually? That is not there in grade 10. Therefore, I am not taking that, Milan. I hope you understand. There are many other things. There is a Bayes formula as well. There are independent events as well. There are many things in probability which is not there in grade 10. So we are going to do about grade 10 board exams only. I hope you understand that, Milan. Spade is a type of black card, Rifka. Spades and clubs are black cards. 13 spades are there, 13 clubs are there. Okay, there is no scientific meaning to that. Okay, and what is the probability of a spade? You just need to know the number of it. You are not playing cards actually, you are just finding probability. You got it or not? I have never played cards in my whole life. But I can do these questions because I just know the numbers over there. I am not able to understand. What is? Not able to understand your question, Tanishka. No trick as such. See, that is, you just have to do questions. Just try to do as many questions as possible. You will be able to remember. So in total, how many spades are there? 13 spades are there in a pack of cards. So the probability will be 1 by 4. So probability of getting a spade when you draw a card from a well shuffled deck of cards, the probability is going to be 1 by 4. Is it clear? I hope it is clear. Yep. See, I am being very, very honest. I would be blatantly honest with you. In mathematics, there are not many tricks to remember things. It's about practice. Even if, see, what will happen, you will forget those mnemonic as well. You understand that or not, guys? If you practice enough number of questions, automatically you'll remember. That's it. Now, what about the last part, the Queen of Diamonds? What is the probability of getting Queen of Diamonds over here? No, it is not there in 10. Milan, it is not there. See, name by name, mutually exclusive, inclusive, independent events and Bayes formula. And there are many other things. They are not there in grade 10, Milan. I am talking about CBSE grade 10. It must be there in some state board. You are right. Maybe in some state board. I am not sure. Maybe in ICSE. In ICSE, it must be there. I am confirm about that. So the Queen of Diamonds. So probability of Queen of Diamonds, only one queen will be there in diamonds, right? So 1 upon 52. Probability of Queen of Diamonds will be 1 by 52. That's it. Very good. Very good, Jayashree, Vinay, Vignesh, Tanishka, Shakil, Babuan. Very good. Rifka, Bhagwan, Shakil. Okay, let us do other questions. Exactly. Okay. Now what about this? A card is drawn from well shuffled deck of, what is the probability the card drawn is neither a king nor a queen. Neither a king nor a queen. What about this? Tell me quickly. Okay, Milan, you are here to learn, but we are going to talk about CBSE grade 10 maths only, Milan. You understand that there is some limit if you are talking about some course, right? So this is board Brahmastra series on the Don't Memorize YouTube channel for grade 10 CBSE students. I hope you understand. See, other students will get confused or not. I can explain Bayes formula as well. I don't have any problem. I can explain permutations and combinations as well. But obviously, I'll not do that. I hope you understand that. I can explain binomial distribution as well over here. Okay? So neither a king nor a queen over here. So how many kings are there? In total 4 kings are there and in total 4 queens are there. So how many kings and queens are there in total? In total 8 kings and 8 king and queen are there. So the question is neither a king nor a queen apart from kings and queens. So you have to do what? 52 minus 8. So what will you get, guys? Over here you will get 44. So the probability will be 44 upon 52. So what is that over here? 11 upon 13. So the probability of getting neither a king nor a queen is 11 upon 13. Very good. 11 upon 13, Babuan, you must have done some mistake. Just check your answer. Exactly, 44 upon 2 is correct, Bhagwant. Yes, Akshita, that is correct. Spot on level. Where are you getting in decimal? Not able to understand that. Yeah, option A is correct, Vignesh. Is this clear to everybody? You have to find neither a king nor a queen. It means every card apart from king and queen. So total 8 kings and queens total will be there. So cards, number of cards apart from kings and queens will be 52 minus 8, that is 42. So probability will be 42 upon 50, 11 upon 13. I hope it is clear. Okay, spot on, no problem. Okay, now you see some other question. It's not on cards and things. Okay, no problem. You don't need to apologize. Just do questions. I'll be more than happy if you are able to do questions correctly. Hello, Anime Village. So what about this? Two players, Sangeeta and Reshma, play a tennis match. It is known that probability of Sangeeta winning the match is this. What is the probability of Reshma winning the match? Tell me. Very simple question. You can just see and tell the answer quickly within seconds. Okay, spot on level. What about this? We already have done that question. Tell it quickly, guys. Tell it quickly. What is mean by at least one? At least means minimum one. At most means max. We'll do a question. We'll do questions like that. Don't bother, Vinay. We'll do questions on at least, at most, like that. Okay? No, Elizabeth. It was 11 upon 13, Elizabeth. You must have done some mistake. Okay, so you see over here, what is the probability of Reshma winning the match? So probability of Reshma winning, I'm writing R just to save time. So probability of Reshma winning will be equal to probability of Sangeeta losing or not. Tell me. Because two possibilities are there. Now probability of Sangeeta winning the match is 0.62. So probability of Sangeeta losing will be 1 minus 0.62 or not. Tell me. So that will be 0.38. Is it clear? Because they are complementary events. Sangeeta winning and Sangeeta losing, they are complementary events or not. So the sum of their probabilities will be 1. So therefore, if the probability of Sangeeta winning is 0.62, so the probability of Sangeeta losing will be 1 minus 0.62. Is it clear? Exactly, that's it. 0.38 is the answer, correct. Yeah, that's it. I mean, Ohm's law, my goodness, we are talking about mathematics and you are asking Ohm's law. Ohm's law is in physics, right? Let's not mix all those things. What about this, guys? What is the answer to this one? Savita and Hamida are friends. What is the probability that both will have different birthdays? What is the probability of both having different birthdays and both having same birthdays? Ignoring a leap year. Yeah, that is correct. V is directly proportional to I. Ohm's law is that. But I would say I is directly proportional to V. I say like that. There is a logic. You can think like that. I is directly proportional to V, I would say, if you ask from me personally. Okay, what about this question? What is the first part? Probability of two friends having different birthdays. Different birthdays means, see, they can have one day, so it's not a leap year, so total 365 days are there in a non-leap year, ignoring a leap year over here. So they can have same birthday only on one day, na? They can have same birthday only on one day out of the 365 days of the year. So probability of their birthdays to be same will be 1 by 365. Yes or no? Probability of their birthdays, same birthday will be 1 by 65, not different birthdays. Will it not be 1 minus 1 by 365 if you understand like this? So it will be 364 upon 365. Because you see, same birthday and different birthday, they will be complementary events or not? Tell me. Two people having same birthdays. So probability of two people having same birthday plus probability of two people having not same birthday will be 1. So not same birthday means different birthdays. You got it or not? Not same birthdays means different birthdays. Okay, 365 is correct over here. Yes. Any doubt to anybody? Hello, J Engineering. So late today. Is it clear to every student over here? Any doubt? Just tell me quickly. Okay, Shakil, Vignesh, Deshika, spot on level. Very good. Okay, Babuan, J Engineering. Let us do more questions over here. Now you see we have got at least at most question. I think one student was asking. Vinay, you were asking? Complementary event we have already done, Vinay, in today's class itself. Please go back and watch it because see, we can do more questions on the basis of that. So I'll tell it quickly. Complementary events are those two events whose sum is 1. For example, I'll tell you quickly, probability of happening of something, probability of an event E plus probability of an event not E. So these are complementary events. It means happening of something and not happening of something. So these are known as complementary events, and the probability, some of the probabilities of them will be 1. I hope it is clear. Vinay? Chalo. Okay, what about this? Two coins are tossed simultaneously. What is the probability of getting at least one head? So the first thing is you have to write all the possible outcomes in order to find the probability. Otherwise you cannot do that. Okay, Vijay. So what about the first part over here? Probability of getting at least one head when you toss two coins simultaneously. 50 upon 50? What is that? Obviously, see, you have to do some sample papers as well, Sahib. I would say typology of the questions would be enough, but still you have to practice sample papers. I hope you understand that, because it is about practice also, na? It's not that you will do 50 questions and you will say, I'm good at that. I hope you understand that. 7 by 8, where are you getting? It will come in 3 coins, right, Vinay? Okay, fine. See, so I will explain one thing, just see it very patiently. It's a very important concept. See it very patiently, guys. See, when you toss one coin, the possible outcomes are head, tail, one coin, right? See it very patiently, it is very important. Please see. When you toss one coin, possible outcomes are head, tail. See it. When you toss two coins simultaneously, 4 possible outcomes are there. How will you write? Take the outcomes of one coin 2 times. Take the outcome of one coin 2 times. Now 2 times write heads and 2 times write tails. You got it? Take the outcome of one coin, write it 2 times, head, tail, 2 times write heads and 2 times write tails. Now 3 coins can also be asked, that is also there in the syllabus. What will you do in 3 coins? See, for 3 coins, what will you do? Take the outcome of 2 coins. Take the outcome of 2 coins, head, tail, head, tail, tail. Write it 2 times. Head, tail, and tail. Now what will you do? 4 times write heads, 4 times write heads, and 4 times write tails. So these are the possible outcomes in case of 3 coins. Possible outcomes in case of 2 coins, possible outcomes in case of 1 coin. Is it clear? How to write outcomes is clear or not? This is a very important thing to understand. I'll explain that as well, Shakil, don't bother. Oh, right now we are doing these questions, Milan. I hope you understand. We have got to do many more questions and we are short of time actually. So is it clear how to write outcomes? Just please make sure in the chat. Is it clear how to write the outcomes in case of toss of coins? It is very important, very helpful. For 1 coin you will do like this, for 2 coins and for 3 coins like this. Is it important or not? Is it clear or not to everybody over here? Now you see, let us do questions for 2 coins according to this question. So we are going to talk about this. At least one head. At least means what? Minimum one head. So at least one head means 1 head and 2 head will also be counted. You got it or not? Because it is at least. Understand the English written over there. At least means minimum. So you have to take 1 head at least and 2 heads as well. So you see 1 head will be counted and 2 heads will be counted. So the probability will be 3 out of 4. That's it. Is it clear? No, Milan, we don't have enough time. I hope you understand that. Okay, Babuan. Is it clear? Okay, Deshika, I'll explain it. Thanks, Akshay. Now what about the second? At most 1 tail. At most means maximum 1 tail. So it means 0 tail will be counted as well and 1 tail will be counted as well. Maximum 1 tail. So 0 tail will be counted and 1 tail will be counted. Both of them will be counted. So 0 tail means what? Just see this. 0 tail means this or not? No tail. And 1 tail. So it means the probability over here will be 3 by 4 again. Is it clear or not? 3 by 4, Akshita? Yeah, that can happen, Aditi. It can depend according to the syllabus. I hope it is clear. Now the last one is very simple, a head and a tail. So a head and a tail, a head, a tail, one head, one tail. So the probability is going to be 2 by 4. So the answer is 1 by 2. Is it clear, guys? Tell me quickly. Just reply that quickly, guys. Is it clear to every student over here? Okay, I'll explain one more thing quickly. Just see over here. I'll explain one more time. Just please concentrate. How will you write the set of all possible outcomes in case of toss of coins? The first thing is, for one coin, the possible outcomes are head and tail. That's it. For two coins, what will you do? Write the outcomes of one coin two times. Head, tail, head, tail. Two times you have written. Not two times write heads and two times write tails. So you will get outcomes for two coins. Now how will you write outcomes for three coins? Write the outcomes of two coins. See, 4 outcomes and again write it, 4 outcomes. Now what you will do? 4 times write heads and 4 times write tails. I hope it is okay now. Deshika, you were asking. I hope it is clear. Milan, I hope it is clear. Now the question is at least one head. At least one head in case of two coins. So at least means minimum one head. So therefore one head will be counted and two heads will be counted. At least means that, guys. One head and two heads. So one head will be counted, one head and two heads. So 3 by 4 is the probability. And see, at most one tail. At most one tail means maximum one tail. So obviously 0 tail will be counted and 1 tail will be counted. So 0 tail means both heads are there and 1 tail is this. So therefore 3 by 4 again. Now third one is very easy, a head and a tail. So in 2 over here you are having 1 head and 1 tail. So the probability will be 2 by 4, 1 by 2. I hope it is clear. Any doubt to any student over here? Just let me know that quickly in the chat, guys. Is it clear to every student over here? Because we have to do some card questions as well. We'll do, I'm sorry, not card, dice. Now you do this, see 3 times over here. All heads, at least 2 heads. Tell me, what will be, how you'll do this? Very important question. These can be asked in the examination. So how will you write all the possible outcomes? Event 1 and 2 are same. No, it's not. Yeah, that can happen. You don't have to bother about that, Subhajit. You just have to do according to the question which is asked. Don't bother about that, right or not. I hope the logic is clear to you. Day's question. Not able to understand that, Anik? So many more questions are there. So 3 times, see, actually I remember how to write the outcomes. What I do is I do like this: head, 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 tail, head, tail, head, tail, head, head. Then I will take tail, tail, tail. Then I will take tail, tail, head. Then I will take tail, head, tail. Then I will take head, tail, tail. Have I got 8 outcomes? 1, 2, 3, 4, 5, 6, 7, 8. So this is another way of writing outcomes in case of 3 coins. What I have done is, see this logic as well if you want to understand. If you want to understand, that can also be done. See, first I have written all heads. Then I have introduced one tail over here. Then I am just shifting this T. You see, I am just shifting this T. Then I have written all tails. Then I have introduced one head. Then I am just shifting these heads. You got it? So I have got 8 outcomes. This can also be done. So the question is all heads. So all heads will come only in one case. So the probability is going to be 1 by 8. That's it. Probability is going to be 1 by 8. Second part is at least 2 heads. At least 2 heads means what? Minimum 2 heads. So 2 heads will come and 3 heads will come. You got it? 2 heads will be counted and 3 heads will also be counted. So 2 heads, what are the cases in which you are having 2 heads? So you see 1, 2, 3, right? And 3 heads will also be counted. So what is the probability, guys? Let me see once again. 1, 2, 3, 4. So it will be 4 upon 8. So the answer will be 1 by 2. That's it. Is it clear, guys? Is it clear to every student over here in the class? Just let me know that in the chat. how I have written these outcomes over here and how we have got the answer. This is a very important, these type of questions are important. I cannot say that this will come or that will come. They can just change the questions according to their will. That's it. But this situation, if you are able to understand this situation, you will be able to do any question. Okay, no problem in that. Is it clear? If suppose you are able to understand the situation, you can do any question, no problem. You don't have to mug up basically. You just have to understand logic. It is mathematics, guys. Come on, it is mathematics. Okay, what about this? The probability of getting 53 Sundays in a leap year. What is the answer? Tell me. 53 Sundays in a leap year. Now these are NCERT questions. Don't forget that. I'm not taking any question which is beyond your syllabus. Either NCERT questions I'm taking or I'm taking sample paper questions. So what is the answer to it? Probability of getting 53 Sundays in a leap year. Okay, so see, in a year, okay, J engineering, maybe if you have practiced enough number of questions, you must remember the answer although. No, not like that, Vinay. No, Vinay, I'll explain it. See, so the answer will be 2 by 7 over here basically. See, I'm explaining it. In a leap year, total 366 days are there. You already know that. Now in any year, 52 weeks are there. You know that. 52 into 7 will be 364. So it means 52 Sundays are fixed in any year, whether it is leap or whether it is non-leap. I mean, whether it's a normal year or a non-normal year, whatever you may call. So in a normal year or in a leap year, 52 Sundays are fixed, or 52 days of end of the week. I mean, any day of the week will be 52 in a year. That will be fixed, right? Now, it means 364 days are already exhausted. Okay. Now, how many days are left? We are left with 364. We are left with 2 days now. Okay. Now, see, 52 Sundays are already there. Now, I want one more Sunday in these 2 days. I want one more Sunday in these 2 days. You got it? Now, how can that Sunday happen in these 2 days? 2 days of a week, 2 continuous days of a week can happen like this or not? Tell me. It can happen in 7 ways possible. Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, wait, Friday, Saturday, and Saturday, Sunday. Yes or no? So these 2 days can happen in these ways possible, 7 ways over here. And over here, how many times Sunday is there? You see, in this Sunday is coming and in this Sunday is coming. So what is the probability? Can you not say in 7 ways, out of these 7 ways, in 2 ways Sunday can happen? So therefore the probability will be 2 by 7. Is it clear? Is it clear to every student over here? Any doubt in this question? Very good, J Engineering, Shubhajit. Okay, Bhagwant Dara, I think. Is the question clear to every student over here? This is an NCERT question. It can be very well asked in your board exams. Is it clear, guys? Just let me know that quickly in the chat. Okay. Now one more question over here. What about this, guys? What is the answer to this question? In a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after she starts playing. What is the probability that the music will stop within the first half minute after starting? What happened, Vinay Kumar? Is it not clear to you? What is the answer to this question? Now this is again a direct NCERT question, I am telling that. What is the answer to this one? I think from examples it is. I don't remember that although. So you see, basically 2 minutes are there, right? And you want to stop the music in the first half minute. So you see, if you make the, suppose I'm making like this. Suppose this is the first 30 seconds. Now this is 1 minute, right? And I can do like this. This is 1.5 minute. Yes or no? And this is 2 minute over here. So if you want to stop it in the first 30 seconds, in this gap, so what will be the probability? See, all of these gaps are equal or not? Tell me. All of these gaps are of 30 seconds, 30 seconds. So if you want to stop the music in the first 30 seconds, will its probability will not be 1 by 4? Tell me. The probability will be 1 by 4. That's it. Very good. Deshika, you must have done some mistake. Some slight mistake. Vignesh, that is correct. Very good, J Engineering. Thanks, Bhagwan. Is it clear to every student over here? Any doubt in this question? You want to stop music in the first 30 seconds, guys, over here, right? So you see all of these are equal gaps of 30 seconds or not? 30 seconds, 1 minute, 1.5 minute and 2 minutes over here. So in the first 30 seconds, if you want to stop the music, so you will say its probability will be 1 by 4. That's it. Yeah, you can think like that as well, Bhagwan Das, because you are changing it in seconds. That is also correct. That is also correct. Harshita, I had already explained what do we do when slant height comes decimal root. See, most of the times you will not get a calculation like this. I would say to watch the recording of the first session of surface areas and volumes on the Don't Memorize YouTube channel, Harshita. I would please say that, because see, we don't have, already we are past the time, right? Please do that. Please watch the recording. In that, I had taken 2 questions in which calculation is there of specifically slant height, which you are asking, Harshita. And there is a calculation in that. You will very well understand that. Please do that. Okay. I hope it is clear to everybody over here. Okay. Now what about this? Can you tell me the answer to this question? This is the last question which we are going to do right now. We are going to have one more session from 4:15. 4:15 to 5:15 we are going to have one more session in which we'll do more questions on statistics and probability. Please do that, Harshita. Yes, Dracula, I can remember you. I can remember the names of every student who come regularly. Okay. What about this, guys? From 4:15 to 5:15, we are going to do one more session on more questions, wherein we are going to do more questions on statistics and probability. And in that only I'll take dice question. Dice question we are not able to do. See, I'm also tired. I want to drink water, right? What are you? Yeah, I have already said that, Dracula, that I can remember you. Okay, suppose it is given a missing helicopter is reported to have crashed somewhere in the rectangular region as shown in the figure. What is the probability that it crashed inside the lake shown in the figure? Direct question, guys. You cannot say that it's tough. Okay, so you see this is 4.5. So this total will also be 4.5, guys. And this is 2, so this will also be 2. So this will be 2.5 or not? Tell me. Because this total has to be 4.5. Clear? Now you see this total is 9 over here and this is 6 over here. So guys, this will also be 6 or not? Tell me. This thing will also be 6. So basically this thing will be 3. So this will also be 3. So what is the probability that it will fall inside the lake over here? Tell me, guys, will it not be the area of this rectangle, that is 5 into 3 divided by the area of the whole forest area, whatever it is. So it is 4.5 into 9. 4.5 into 9. So this is the answer to this question. That's it. You can simplify, remove the decimal over here. So it will be 10 upon 27. Is the question clear to every student over here? Okay, Anime. Is the question clear? Any doubt? I am taking most of the questions from your sample papers only. And I have covered, I think, almost the complete sample paper of this year and the previous year. So please check the Don't Memorize YouTube channel and check out the playlist named as Board Brahmastra over here. And I'm 100% sure and confident about that you will benefit from that. Please see that. So is the question clear to every student over here? Any doubt in it? 1 by 6 you are not going to get. Just check your answer, right? So it is clear to everybody over here, guys. See, I'll do once again over here. Suppose Oh my god, I did a mistake. Wait for some seconds. Oh my god, this was 2.5. It is not visible to me. Oh my goodness. Due to yellow color, I was not able to see. Wait. So basically, it will be area of this thing, right? So this is 2.5 into 3, right? So it is 2.5 into 3 divided by the area of the forest over there. So it is 9 into 4.5, right? So this is correct. 9 into 4.5. It is okay now? So you see 3 3s are 9, 5 5s are 25, 5 9s are 45. So this will be the answer. Is it clear, guys? I hope it is clear. Yes, I hope it is clear, Bhagwant. Yes. The value I was not able to see. Actually this 2 was not visible to me. I had taken it to be 5 over there. I hope it is clear now. Yes, that is clear. Any doubt to anybody? This is a direct question, guys, on probability. It's not a very complex question. It's a direct question, right? So that's all we needed to discuss in this class, guys. After this class, you are going to have one more session from 4:15 and we are going to do more questions on statistics and probability. So join this session from 4:15, guys. I'll be back after 10 minutes. Okay, guys, bye-bye. We'll meet in the next session. Take care, everybody.